In the vast silence of space, a lone emissary continues its endless journey, carrying the hopes, curiosity, and ingenuity of a small blue world. That traveler is Voyager 1. Launched in 1977, it has been moving outward ever since, farther than any object humans have ever built. Now, nearly 5 decades later, Voyager 1 is about to reach a symbolic milestone. 1 light day from Earth. That's the distance light travels in 24 hours. By November 2026, the spacecraft will be so far away that a radio signal will take an entire day to reach it and another day to come back. A simple hello from Earth will take 48 hours to complete its round trip. And in that quiet delay lies both science and poetry, a living reminder of how far human curiosity has traveled. The journey outward. Voyager 1 left Earth on September 5, 1977, just weeks after its twin, Voyager 2. The missions were timed for a once-in-176-year planetary alignment that allowed the spacecraft to visit Jupiter and Saturn and then use their gravity to slingshot outward. After its Saturn flyby in 1980, Voyager 1's path bent steeply above the plane of the planets, setting it on course to leave the solar system entirely. It travels at roughly 38,000 miles per hour, about 17 kilometers per second. In human terms, that's impossibly fast. In cosmic terms, it's a crawl. Decade by decade, this patient motion carried Voyager through the frontier. In August 2012, it crossed the heliopause, the invisible boundary where the solar wind from our sun yields to the pressure of the interstellar medium. That crossing marked the first time humanity had touched another region of space beyond the sun's effluence. Today, Voyager 1 is 15.7 billion miles away. By late 2026, it will pass 16.09 billion miles, 1 light day. It's a distance that transforms how we communicate and how we think about connection itself. A 1 light day conversation. Once Voyager crosses that threshold, every signal from Earth will take a full day to reach it. Another full day for its reply to return. A conversation that once took minutes now takes 2 days. This means engineers can no longer make quick corrections or adjustments. Each command must be planned far in advance, and every response patiently awaited. It's a dialogue stretched across time, a slow heartbeat between worlds, and yet those faint signals still reach us. The Deep Space Network giant radio antennas in California, Spain, and Australia listens constantly. By tracking tiny Doppler shifts in Voyager's radio signal, scientists measure its speed and distance with breathtaking accuracy. The 1 light day milestone isn't just a number. It's a symbol of endurance, precision, and human patience. Listening from the edge. Though far beyond any planet, Voyager 1 still teaches us about the unseen spaces between stars. Its plasma wave instrument detects ripples moving through the thin interstellar plasma. When solar storms erupt, their shockwaves travel billions of miles, and Voyager can still sense their passing. These signals show that interstellar space isn't silent at all. It vibrates with faint echoes of solar activity. Its cosmic ray detector measures high-energy particles that come from outside the solar system, relics of supernova and ancient galactic events. These readings help scientists understand how cosmic radiation moves through the galaxy and how our sun's magnetic field shapes that flow. Meanwhile, Voyager's magnetometer continues to map subtle changes in magnetic fields, showing that the interstellar medium is dynamic, not uniform, a landscape alive with structure and motion. Each new transmission adds to humanity's first direct sampling of the space between the stars. Engineering built to endure. Voyager 1 is a triumph of durable design. Its systems were meant to last only 5 years, long enough to complete the planetary tour. Yet, through decades of careful management, it still operates. In 2017, NASA engineers pulled off something extraordinary. They reactivated backup thrusters that had T-fired since 1980 to adjust the spacecraft's orientation and keep its antenna aimed precisely toward Earth across 15 billion miles, Those tiny pulses worked flawlessly, giving the mission new life. Voyager's greatest limitation now is power. It runs on a radioisotope thermoelectric generator, or RTG, which converts the heat from decaying plutonium-238 into electricity. Each year, its power output drops by about 4 watts. To conserve energy, NASA has gradually turned off instruments and heaters, keeping only the essentials alive. At some point, likely around 2036, there won't be enough power left to send data home. When that day comes, Voyager will go silent. But silence will not mean failure. It will mean completion, a handoff to eternity. Beyond communication after its final transmission, Voyager 1 will continue outward at about 3.6 astronomical units per year, roughly the distance from the Sun to Jupiter annually. In about 300 years, it will reach the inner edge of the Oort cloud, the spherical shell of icy bodies that marks the solar system's farthest frontier. Crossing that region could take 30,000 years. After that, Voyager will drift endlessly through the Milky Way. Its trajectory will carry it toward the constellation Ophiuchus. And around the year 40,272 AD, it will pass within 1.7 light-years of a dim star in Ursa Minor. By then, it will have been silent for tens of thousands of years, but it will still carry something unique. The golden record bolted to the side of the spacecraft is a gold-plated copper disk, a time capsule from Earth. It contains sounds, images, and greetings in 55 languages, from the music of Bach to the sound of a heartbeat, from a mother's kiss to the rumble of thunder. Engraved on its cover are diagrams explaining how to play it and where it came from, in the faint hope that one day another intelligence might find it. Even if that never happens, the record is a symbol, proof that humanity once reached beyond itself to say, "We were here." Lessons from a one-light-day journey. This milestone teaches us more than physics. It teaches perspective. At one light day, we see how immense space truly is and how small Earth remains. We learn that exploration is not only about speed, but about endurance. Voyager's survival proves the power of resilient engineering and persistent curiosity. Every signal that still reaches us is a triumph of patience and foresight. It also shapes the next generation of explorers. NASA's proposed interstellar probe concept, inspired directly by Voyager, aims to travel even farther with more advanced instruments and power systems. What we learn from Voyager's decades in deep space will guide how we build and sustain missions in the future. Yet perhaps Voyager's most lasting legacy isn't technical, it's emotional. It reminds us that curiosity travels faster and farther than any spacecraft. We are a species that listens for echoes in the dark, waiting patiently for a reply. The quiet, enduring signal as Voyager 1 nears one light day. Its voice grows faint, but not forgotten. Each photon of radio energy that leaves its antenna crosses billions of miles before brushing Earth's detectors, the smallest whisper still heard after 48 years. When that signal finally fades, Voyager's story will remain. A story of determination, ingenuity, and wonder. For long after the lights of our civilization change, long after languages and nations evolve, Voyager 1 will continue its path, a messenger of our time, carrying a small golden record of who we were. As it drifts beyond the reach of our voices, Voyager 1 remains a part of us, still carrying the memory of home. Its signal may fade, but its meaning endures. Proof that curiosity can outlast the limits of time, and that somewhere, far away, a human artifact continues its endless journey into the deep.